Okay, welcome to this video on the electromagnetic spectrum. I'm going to describe how the electromagnetic spectrum is formed, how the wave is formed, and you don't really often hear people talking about that. And then we're going to talk about some of the uses and go through some details on each part of the electromagnetic spectrum. So let's talk about how waves are formed to start with. Let's start by thinking about sound waves particularly. Now here we've got a vibrating guitar string. The string is vibrating backwards and forwards, and what that's doing is creating what are called pressure waves. It's causing areas of increased pressure in the air, and that's sort of interspersed with areas of decreased pressure. So we've got various high pressure areas interspersed with various low pressure areas, and this forms a wave, a longitudinal wave, what I call a squash wave. And these squashed bits of air move from the guitar through the air at about 330 meters per second at normal sort of temperatures and conditions, and this sound hits your eardrum, it vibrates your eardrum, and your brain interprets this as sound. So there's a key sort of fundamental principle of waves, and that is that waves are created by vibration. So the example of the guitar string, for example, here in this picture you can see an earthquake. Now the earthquake is the vibration, and that's causing a wave in the water. It's causing this tsunami. So waves are caused by vibrations, and that is also true of electromagnetic waves. Now, what's the sun made of? Most of the sun consists of a substance called plasma. Now plasma is a bit like a gas in that the particles are zooming around all over the place and banging into each other, but they're not actually particles. They're not atoms and they're not molecules. They're charged particles called ions, and they're zooming around. So they're things like electrons and protons moving around very, very fast, and that's plasma, and that's what the sun is made of. Now the hotter it is, the faster those charged particles are going to move. Now, just as a vibrating guitar string gives off sound waves, moving charges in the plasma of the sun create waves in what's called the electromagnetic field. Now this field, it's not made of anything, it's not made of any atoms, it's just a field like a magnetic field or a gravitational field. So we've got this electromagnetic field that permeates all of space, up, down, left, right, backwards, forwards. All of space is permeated by this electromagnetic field. And the moving charges, the moving electrons and protons, cause vibrations in the field. And these vibrations form a wave. A water wave needs water molecules to move through. A sound wave needs air molecules to move through. But an electromagnetic wave can move through the vacuum of space. So I'm not suggesting here that there is a medium to move through. There's not. It moves through nothing. However, the wave itself is a wave in the electromagnetic field. Okay. Now, the very fast moving ions in the plasma will create high frequency waves, and the very slow ones are going to create low frequency waves. So down by here at gamma rays, we've got very high frequency, low wavelength waves that carry a huge amount of energy. And then all the way up the other end, we've got long wavelength, low frequency sound. And these ones here are created by the slower moving ions. So this electromagnetic wave, or these waves, travel through space at the speed of light. And when they touch the human eye, for example, we can detect it. The human eye can detect this frequency here, 430 to 770 terahertz. And we see that bit. There are animals that can see ultraviolet rays. There are insects that can see UV. They can see those frequencies. There are snakes, pit vipers, that can see heat. They can see infrared. There's these little pits in their noses that means they can see that frequency. For us human beings, we can see this frequency here, 430 to 770 terahertz, and we interpret that as different color light. Here's a summary of the different kinds of waves. Now we've got the high frequency waves, which, like I said before, have the shortest wavelength, and the low frequency wave has the longest wavelength. Now you need to be able to label the EM spectrum, and you need to know the uses of each component part. So what are X-rays used for? They're used for medical imaging of bones. Ultraviolets are often used for sunbeds or phototherapy for things like for certain skin conditions like acne. So you need to know, you need to have examples of the uses of each of these types of radiation. So it might be an idea now for you to pause the video and just jot these down in your notes if you haven't got them already. Now, frequencies lower than that of visible light, lower frequencies, higher wavelengths, so we're talking about infrared, microwaves, radio, TV waves, and long radio waves. These ones have a general heating effect. And you can see this here. One of these waves is infrared. Let's talk about infrared first. That's the next one. So you've got all the colors of the rainbow, which the eye can see, red, orange, yellow, green, blue, indigo, violet. And just off the red end of the spectrum is infrared. Now that's essentially heat. And you can see in this image here, this thermal image, this thermogram, the different colors. So we're seeing in heat now. So we're seeing in sort of, we're assuming this is the sort of thing that a pit viper could see. So even if there wasn't any light, you could actually see this heat with an infrared camera. Now the hottest parts are the whites and the reds, and the coolest parts are the blues and the greens. So we can actually use a camera to see infrared. This diagram here shows that dull black surfaces are the best absorbers of infrared. I've got a bulb here chucking out a huge amount of heat, knocking out a lot of infrared, and these thermometers in these aluminium tubes show that the shiny surface is not absorbing a great deal. A lot of it's being reflected off, so the temperature's not going up very much. However, this dull black surface, as you're aware from experience of going out on a hot sunny day wearing black or wearing white, this dull black surface absorbs a lot of the infrared, and so it heats up a huge amount, and this thermometer is showing that. So dull black surfaces are the best absorbers of infrared radiation. Now this one, we've got this hot metal structure here, this sort of metal prism, and we've got a dull black surface and a shiny white surface. And what's happening here is this thing is giving off heat, it's radiating heat. And we can see here this thermometer is the highest. It's got the highest reading of the temperature because this surface here is emitting infrared. The shiny white surface is not. It's not emitting so much. So not only do dull black surfaces absorb the most infrared, they also emit the most infrared as well. They're the best absorbers and the best emitters of infrared. Microwave ovens. Now these rely on the ability of microwaves to penetrate into your food and vibrate the water molecules inside. They penetrate about 1 centimeter into your food. That's why generally you have a plate spinning around. Otherwise, if a big lump of food stayed still in your microwave, about 1 centimeter in would get very, very hot and not much else would happen. So you've got microwaves which are vibrating the water particles. Dry foods don't tend to cook very well in microwaves because they haven't got much water in them. You need water to vibrate. Now the microwaves can go through plastic and glass, but they're reflected by metal. Now you might be thinking, hang on a minute, well surely the door of my microwave is plastic or glass, so why don't the microwaves come out and heat me up or heat my kitchen up? This glass here has a metal mesh, so that stops the microwaves coming out, and they just bounce around and around and around inside your microwave. So glass and plastic, microwaves will go through, but metals, it will vibrate around, it will bounce off of. So that's microwaves. Mobile phones also use microwaves, low intensity microwaves for communication. When you're using a mobile phone, you're essentially holding a low intensity microwave emitter right next to your head. You can also get microwaves coming off of these transmitters, these base station transmitters as well. Now these things do have a slight heating effect, but it's never been proven to be damaging to human beings, not yet anyway, but we're going to wait for the long-term studies to come out. But so far, no evidence that it's that damaging. And if you want to minimize the effect of this, then use a hands-free kit or limit your time on the mobile phone. Okay, let's talk about frequencies higher than light now. So we're talking about high frequency, low wavelength, a lot of energy in these things. Now there's generally a rule. Although this is a wave, the energy is carried in little packages called photons. And if you have high frequency waves, these photons contain a huge amount of energy. So these gamma rays here, the high frequency gamma rays, these carry the most energy. And that's why they're the most damaging. So you've got really damaging, ionizing, high frequency radiations here. Unpleasant, UV. Look at this. This guy here has got some skin cancer. He's got some severe sunburn and skin cancer. UV is mildly ionizing, but it can still cause burns, skin cancer. In this picture here, of the eye, this is a cataract. This is where the lens of your eye goes milky and white, and it's like, kind of like looking through frosted glass. You can get this sorted out now with laser eye therapy, laser eye treatments. But yeah, if you have long-term exposure to UV light, then you're going to burn your skin. You're going to get skin cancer. You're risking skin cancer, and you're risking cataracts as well. So there's a damaging effect or an ionizing effect. X-rays. I'm sure you've all been in this situation where you've been at the dentist or the doctors and they've set you up with an X-ray, and then they leave the room and you hear the little click and then they come back in again, and you're thinking to yourself, well, hang on a minute, if these things are damaging, so damaging that you have to leave the room, am I going to be damaged? Well, no, because your dentist and your doctor do, 10, 20 of these per day. They do a lot of these every day. And if they were exposed to X-rays like this every single day of every single week, then there's a high chance that they would develop cancer or something like that. You are limited to how many X-rays you can have in a year. There comes a point when it becomes unsafe to have too many. Because again, X-rays are ionizing. They're high frequency waves and they can do some damage. So that's X-rays. Now, how does a picture like this form? In this case, this person's rested their hands on some white photographic film. Now, materials like skin and bone can absorb X-rays, but the amount of absorption depends on how thick and dense the material is. Now, bone obviously absorbs quite a lot of these X-rays, so the plate underneath remains white. It doesn't get developed because the bone has absorbed practically all of the X-rays. Whereas the soft tissue, the X-rays have gone through to a degree, hit the photographic film and turned it from white to black. So you can see the black of the normal photographic film. You can see the grey area where the soft tissue has absorbed some of the X-rays but not much, and you can see these white areas down here, really dense bone where most of it's been absorbed and the film underneath has not been developed one bit. All the way down, nearly finished, we're at gamma rays now. Gamma rays, these are super high frequency waves. These photons contain a lot of energy. Now the kind of ironic thing is, radiation can give you cancer, gamma rays can give you cancer, but gamma rays can also be used to treat cancer. High frequency gamma radiation can be used to identify cancerous tumours, and it can also be used to destroy those tumours. Also used medically to sterilise equipment. So you could put a scalpel in its little container, seal it up, blast it with gamma rays, and it would be sterile. And you know that when you open that bag up and pull that scalpel out, it is going to be sterile, and you're not going to get any nasty infections from it. So there we are. I've hopefully explained to you how electromagnetic waves are formed from the plasma, from the ions vibrating and the setup of the waves in the electromagnetic field, and we've talked about the different parts of the electromagnetic spectrum and what they're used for and what are some of the dangers of them. I hope that was useful to you. Thank you very much for watching.